Welcome to the celebrated High Achievers Mentorship Program, CHAM. We are bringing academic dreams to reality. So in this video, I will be talking on stoichiometry. Stoichiometry. Now, stoichiometry is derived from two Greek words, stoichion and metro. Stoichion means what? Atom, while metric means measurement. So stoichiometry is essentially the measurement of atoms. Yes, let me talk on the mole concept now. So I will give some formulas on the mole concept. Then we'll begin to take questions. Yeah. So what's the first one? Mole is equals to mass over molar mass. Anytime you know the mass of a substance and you are asked to find the mole, just find the molar mass of that particular compound. Yeah. So that we get to the mole. The next mole is also equals to volume over molar volume. And for a gas, the molar volume is always what? 22.4 dm3 or 22,400 centimeter cube. So if you are given in centimeter cube, you use this. If you are given in dm cube, you use what? You use this. Number 3, mole is equals to concentration times volume. Your concentration is in what? Mole per dm cube. While your volume is in what? Is in dm cube. Yes. So mole is equals to concentration times volume. Then we also have mole is equals to PV over RT. Yes, this is your pressure, this is your volume, this is your rate, the gas constant, and this is what? The temperature. So we have pressure times volume over what? R times temperature. Yes, this is actually derived from the ideal gas equation. PV is equals to nRT. So your N is equals to what? PV over RT. So this is your N, which is the number of moles. That's what you have here, PV over RT. And please note that N is also equals to what? The compressibility factor. The compressibility factor. Another thing that you need to note is that in this formula, your the unit for your R is always a constant. 0.082 atm dm cube per mole per Kelvin. What is that to tell you? That is to tell you that this atm, your pressure must always be in what? atm. So let's say you are now giving a pressure in millimeter mercury. Let's say you are giving a pressure to be 770 millimeter mercury. How do you change it to atm? You divide by what? Divide by 760. Another case, let's say you are giving 870 millimeter mercury. To convert it to atm, you do what? You divide by 760. How do we get about this conversion? How do we get about dividing by 760? Yes, it's very simple. Yes, let me just prove that. Yes, this is it actually. You know that 1 atm should give you what? 760 millimeter mercury. Then x atm, which is what we are looking for, should give you, let's say we are giving 870. So cross multiply 1 times 870, that will give you what? 870 is equal to x times 760, that's what? 760x. So you divide this side by your 760. Can you see? 870 over 760. Your 760 is always that. Yes. So that's just about that. Another thing is that your volume must be in what? dm cube. So your volume must be in dm cube. So if you are given a volume, maybe 200 centimeter cube, you change it to dm cube. And how do you do that? You divide by 1000. Let's say you are given another one. You are given 576 centimeter cube. You do what? You divide by 1000 to get your what? dm cube. And the last thing is that your temperature must be in what? In Kelvin. Your temperature must be in Kelvin. So to convert temperature in Celsius to Kelvin, just add what? Add 273. So 27 degrees Celsius plus 273 will give you what? 300 Kelvin. Another one, 37 degrees Celsius plus 273 will give you what? 310 Kelvin. So your temperature must always be in what? In Kelvin. Yes, let's take the last equation now, or the last formula for mole. So that's what mole is equals to number of particles over what? Avogadro's constant. What's Avogadro's constant? 6.02 times 10 raised to the power 23. Your number of particles can be 3. It can be ions, it can be molecules, and it can be what? It can be atoms. Yeah, please take note of that. Yes, so number of particles over 6.02 times 10 raised to the power 23. So let's take questions now. But before then, you can write this or pause the video to put this down. So you have mole is equals to mass over molar mass, mole is equals to volume over molar volume, mole is equals to concentration times volume, mole is equals to PV over RT, and number of particles over 6.02 times 10 raised to the power 23. So let me just rub it off. Yeah, I'm sorry, I want us to take questions on it now. Yes. Now, for the first one, we have what? Mole is equals to mass over molar mass. So yes, I believe you all know how to calculate molar mass. So let's just try some things out. Let's find the molar mass of, calculate the molar mass of, let's say Na2SO4, let's say CaCO3, let's say NaCl, and what? KOH. So they will give you like this: Na is 23, S is what? 32, O is 16, Ca is 40, C is 12, and Cl is 35.5. So yes, let's go now. Calculate the molar mass of Na2SO4. So you have Na2. Okay, let me write it first. Na2SO4. Yes, what's your Na? Na is what? 23. 23 times 2. Are you following? Plus, what's your sulfur? Your sulfur is definitely what? 32. Then you have oxygen. Oxygen is 16 times 4. So we have 23 times 2 is what? 46 plus 32. 16 times 4 is what? 64. So if you add it up, 46 plus 32 plus 64, you will get what? 142 gram per mole. So this is the molar mass. The second question, we have CaCO3. What's Ca? That's 40 plus, what's carbon? That's 12. What's oxygen? That's 16 times 3. 40 plus 12 plus 16 times 3 gives you 48. If you add it up, you should get what? 100 gram per mole. The next one now, NaCl. What's Na? Na is what? 23. What's Cl? 35.5. If you add it up, you get what? 58.5 gram per mole. And the last question, KOH. What's your K? K is 39. Oxygen is what? 16. Then hydrogen is what? 1. I don't think I write that. So 39 plus 1, that's what? 40 plus 16, 56 gram per mole. So yes, That's about calculating the molar mass. So I think we should be able to take questions on this effectively now. Yeah, let me rub it off. So yes, let's begin to take questions on this now. Let's begin to take questions on this now. So yes, I'm calling a question now. So yes, I will just write it down. Calculate the number of moles present in each of the following. Roman figure 1, 5.3 gram of Na2CO3. Roman figure 2, 200 centimeter cube of 0.025 mole per dm cube. Roman figure 3, 16 dm cube of hydrogen gas at STP. Roman figure 4, 250 centimeter cube of an ideal gas at a pressure of 720 millimeter mercury at 37 degrees Celsius. Roman figure 5, 4.25 times 10 raised to the power 21 atoms of copper. Oh yes, this is a very great question. So using the formula for your mole, you can be able to calculate it effectively. Yeah, let's recollect. Our mole is what? Mass over molar mass. Our mole is what? Volume over molar volume. And I told you that your molar volume is 22.4 dm cube or 22,400 centimeter cube. Then your mole is what? Concentration times volume. I told you that your concentration must be in mole per dm cube, while your volume must be in what? Dm cube. Mole is equals to, what's the next formula? PV over RT. Then we said mole is equals to number of particles, and I said these particles can be atoms, molecules, or ions over what? Avogadro's constant. Let's go now. First question. 5.3 gram of Na2CO3. 5.3 gram. That's your what? Your mass. So mass is equals to 5.3 gram. So you are given Na2CO3. Let's try to find what? The molar mass, so that we can use this formula. Molar mass is what? Na is what? 23 times 2 plus, what's carbon? 12. What's oxygen? 16 times 3. 23 times 2 is what? 46 plus 12. 16 times 3 is what? 48. If you add it up, you are going to have 106 gram per mole. So what will be your mole? Mole is equals to mass over molar mass. What's our mass? 5.3. What's our molar mass? 106. So try dividing 5.3 divided by 106. That will give you your what? That will give you 0.05 mole. 0.05 mole. So I believe you get it now. Yes, we have been given our mass, so we calculated our molar mass. Then we said mole is equals to mass over molar mass. So you may need to put it down, or yes, let me just clean it, then we move on. So the second question now. We have 200 centimeter cube of 0.025 mole per dm cube. Yes, just identify it. What is this? This is your what? Your volume. 200 centimeter cube. What's this? Mole per dm cube. That's what your concentration. 0.025 mole per dm cube. So this is just the two things you're given. So go to your formula. Which formula relates C and V? So this is C times V. Mole is equals to C times V. So what's your C? 0.025. What's your V? 200 centimeter cube. But I told you that it must be in what? In dm cube. So I can say 200 over what? Over 1000. So we have, you can just cut it. So you have something like 0.05 divided by 10. That's 0.005 mole. So that's your answer. That's your final answer for that. So just check it out while we take the next one. I believe I can claim now. So we have the next question now, which is 16 dm cube of hydrogen gas at STP. So we've been given the volume, 16 dm cube. Yes, I said for a gas we use what? Volume over molar volume. What's the molar volume of a gas at STP? That's what? 22.4 dm cube. So mole is equals to volume over molar volume. Volume is 16, molar volume is 22.4. Yes, what will be 16 over 22.4? Yes, let me just get my calculator press it. So yes, I got 0.71 mole. Yes, so that's just about that. Let me take the next question now. So question 4, you have 250 centimeter cube of an ideal gas. So this is the what? The volume. Should have been the other way around. Something like this. At a pressure of 720 millimeter mercury. 720 millimeter mercury. At, I think this should be 37 degrees Celsius, not 370. So temperature is what? 37 degrees Celsius. Now, what should you use? You have V, you have P, you have T. This is it. VPT. You have your R already. Your R is always 0.082 atm dm cube per mole per Kelvin. So let's move. Mole is equals to PV over RT. What's your P? 720. No, this is it. Remember I told you something that your pressure must be in what? In atm. So how do you convert this one to atm? This will be what? Divided by 760, right? How do you convert this one to Kelvin? Plus 273, 310 Kelvin. How do you convert this one to dm cube? Divided by 1000. We touched this already. So what's your pressure now? 720 over 760 times, what's your volume? 250 over 1000 divided by, what's your R? 0.082 times, what's the temperature? 310. So you can just cut logically. This one we cancel this one. This one we cancel this one. 25 in 100 will give you 4. Then 4 in 72 should give you what? Should give you 18. So you have 18 over 76 divided by, yes, what should this one give you? Let me just get my calculator and press. I'm sorry for the delay, I was trying to get my calculator. So we have, I'm pressing it now, 0.082 times 310. So that's what we have. I'm coming 25.42. So yes, I should have even divided everything straight, but let me just continue. But this is what I should have done. Let me just clean this so that I don't stress you out. Let me press 18 divided by 76 here. 18 divided by 76. So that's what 0.236 divided by 25.42. So that will give me what? I'm pressing it already, divided by 25.42. So here I have 9.317. 9.317 times 10 raised to power minus 3 mole. So this is my answer for this. Yeah. So let me try to explain again. I was given my volume 250 centimeter cube. I divided by 1000 because my volume should be in dm cube. I was given my pressure 720 millimeter mercury. I divided by 760 because my pressure should be in what? atm. I was given my temperature 37 degrees Celsius. I added to 73 because my temperature must be in Kelvin. Then this is my R. So I slot it into this formula. Mole is equals to PV over RT. Yeah. What you would have done if you want to be faster is that 720 over 760, just press it into your calculator, slot it here, times this should be give you 0.25 divided by R is 0.082 times 310. So that will give you a faster way of getting the question. Yes, let's move on now. The last question. So let's take the last question together now. 4.25 times 10 raised to power 21 atoms. So this is what? The number of particles. I told you that your number of particles can be three things: AMI, atoms, molecules, or what? Or ions. So these atoms. So it's number of particles. So we can remembering the formula, recalling the formula, we have mole is equals to number of particles over 6.02 times 10 raised to power 23. Your mole is equals to number of particles, that's 4.25 times 10 raised to power 21 all over 6.02 times 10 raised to power 23. So you are going to have 4.25 over 6.02 times 10 raised to power 21. Division will change to what? Minus. Don't mind me, you can press it straight. You can press it straight. So yes, let me do mine here. So you have 4.25 divided by 6.02. So here I have 0.706 times 10 raised to power minus 2. So my answer is 7.06 times 10 raised to power minus 3. How did it change to minus 3? Because I shifted this one to the front once. So this one too will increase once. So that's minus 3. So this is your mole. Yes. So we are done with the second case now. The first case was calculating molar mass. Then now you can be able to calculate moles. So let's take some past questions on this now. Yeah. So I'll be giving some past questions on this now, so that from there we move on. So yes, the first question I have here, the question says, how many moles of calcium trioxocarbonate or CaCO3 are there in 2.5 gram of calcium trioxocarbonate 4? So this is the question. We were given Ca to be 40, carbon to be 12, O to be 16. So yes, how many moles? Mole is equals to what? Mass over molar mass. What's your mass? 2.5 gram. 2.5 over, what's your molar mass? Ca, that's what? 40 plus. Carbon is what? 12 plus. Oxygen is what? 16 times 3. That's what? 2.5 over 40 plus 12, that's 52, plus 16 times 3 is what? 48. So 52 plus 48 will give you what? 100. That's 0.025 moles. So that's the answer to that. Here, right with me in the question, in the past question where I picked it from is option B. Yes, another question. They said 1 mole of a compound MHCO3 has a mass of 84 grams. Calculate the relative molecular mass of M. Yes, let's say you were given this question. I'm sorry. And you are asked to find the relative molecular mass of M. How are you going to go about it? So you have MHCO3 to give you what? 84. So you don't know your M. What's the molar mass of hydrogen? 1. What's the molar mass for carbon? 12. What's the molar mass for oxygen? 16 times 3, which equals 84. M plus 1 plus 12, that's 13, plus 16 times 3, that's 48, is equals to 84. M is equals to 84 minus 13 plus 48, that's what? 61. That's what? 23. M is equals to 23. So that's the relative molecular mass of M. What what if you are given this one? Just try it out now. You are given something like this. They told you that the 1 mole of a compound, let's say M or XCO3, has a mass of 8400 grams. Yes, they now ask you to calculate the relative molecular mass of X. How are you going to go about it? XCO3 is equals to what? 100 grams, right? You can put it and try it out on your own. X plus 12 plus 16 times 3 is equals to 100. X plus 12 plus 48 is equals to 100. X plus 60 is equals to 100. X is equals to 100 minus 60. X is what? 40 grams. So it's as simple as that. Let's move on now. I'm taking another question now. So in this question you are asked that what is the mass? What is the mass of 2.3 mole of sodium? So this is the question. You've been given your mole, then you are asked to find the mass. What's the formula? Mole is equals to mass over molar mass. What's your mole? 2.3. What's your mass? That's what you are looking for. Over the molar mass. The molar mass of sodium is what? 23. So mass is equals to, you cross multiply 2.3 times 23. That's what? 52.9 grams. Yeah. So that's about that. Yes. Another question, or would you like to try one out? Let's say you are given what is the mass of 2 mole of, let's say, KOH. So let's solve this together. You've been given your mole. Your mole is 2. And you know that your mole is what? Mass over molar mass. So what's your mole? 2. What's your mass? That's what you are looking for. Then your molar mass is what? K is 39. Oxygen is 16. Hydrogen is 1. So 2 is equals to M over 39 plus 16 plus 1, that's 56. So you cross multiply, M is equals to 2 times 56. M is equals to 112 grams. So that's just that. Yes, another jump question here. how many moles of iron how many moles of iron 3 oxide are contained in 1 kilogram of the compound? Yes, let's solve it now. You are looking for your mole. Iron 3 oxide. So this is your mass, 1 kilogram. But in chemistry we use what? We use gram. Because chemistry deals with what? Particles. They are very small. It's only in physics that you are dealing with what is heavier, what is weightier, that you use kilogram. So you change this one to your what? To gram. So that's what? 1000 gram. Yes. So kilogram to gram is multiplying by 1000. Let me just move on. They said iron 3 oxide. What's the formula for iron 3 oxide? Fe2O3. Your Fe is 56. They gave you in the question O is 16. So let's move on now. Mole is equals to mass over molar mass. What's your mass? 1000. What's your molar mass? Iron is what? 56. So this 56 times 2 plus oxygen is what? 16 times 3. 1000 over 112 plus 48. 1000 over 160. So this is what? 50 over 8, 25 over 4. That's what? 6.125 more. So that's just about that. So yes, let me give you one to try out like this. But before then, just go through it again. Mole is equals to mass over molar mass. What's your mass? 1 kilogram. That's 1000 over what's your molar mass? Fe2O3. So what's Fe? Fe is what? 56 times 2 plus 16 times 3. So you have 56 times 2, that's 112, plus 16 times 3, that's what? 48. So 1000 over 160. That gives us this. Yes. Let's say you are giving another one. Let's try it out now. Let's say you are giving, let me just edit it. Of copper sulfate are contained in 2 kilogram of the compound. Cu is 64, S is 32, O is 16. Yeah, so we'll be taking this together now. So yes, let's take this question together now. So you have how many moles? So you are looking for your mole. Are they in 2 kilogram? So your mass is what? 2 kilogram. Convert it to gram will give you what? 2000 gram. So yes, what is the molar mass? Molar mass of CuSO4. That's copper sulfate. CuSO4. What's Cu? 64 plus. What's sulfur? 32 plus. What's oxygen? 16 times 4. So we have 64 plus 32 plus 64. If you add it up, you get 160. So mole is equals to mass over molar mass. What's your mass? 2000 over 160. So if you do it, you get 100 over 8. That's what? 50 over 4. 25 over 2. Then that's what? 12.5 mole. So yes, that's your final answer. Yes, if you are still not able to solve it, you can just play it back, then try it on your own now. There's another jam question on this particular case. Yes, so we have another question here. You have, please, a minute. Okay, so we have a question. Which of the following is the same as 24 gram of magnesium? So you have 1 gram of hydrogen molecules, you have 16 gram of oxygen molecules, you have 32 gram of oxygen molecules, and you have 35.5 grams of chlorine molecules. Then we are given the molar mass. H is 1, Mg is 24, O is 16, Cl is 35.5. Yes? Now, what's the meaning of hydrogen molecules? H2. More hydrogen molecules. Oxygen molecules, O2. O2. Cl molecule, chlorine molecule is what? Cl2. So yes, 24 grams of magnesium should give you 24 over. What's the molar mass? This is the formula we are working with. In case you forgot, mole is equal to mass over molar mass. So for the first question, you've been given your mass 24 over, what's the molar mass of magnesium? 24, 1 mole. So they said which one is the same. So begin to test it. So you have option A, 1 mass over molar mass. Your mass is what? 1. What's the molar mass of hydrogen? That's what? 1 times 2. 1 over 2. That's what? 0.5 mole. Is it the same as 1 mole? No. Option B, 16 gram. That's your mass over molar mass. 32. 0.5 mole. Not the same. 32 gram mass over molar mass of oxygen. 16 times 2, 32. 32 over 32, 1 mole. So this is your answer. Option C is correct. You can try option D too. Mass over molar mass. What's the molar mass of chlorine? So that's 35.2 times 2 divided by 71. That will also give you what? 4.5 mole. Not correct. So that's why we are arrived at C. Yes. I believe you got it now. Yes. So you can just go through it again in case you don't get it. Let's take another question now. So yes, another question under this case, we have what is the mass of potassium hydroxide present in 500 cm cube of 2 mole per dm cube solution of the compound. So you have K to be 39, you have O to be 16, you have H to be 1. So yes, let's try to solve this together now. So we have our mass to be KOH. We are looking for our mass, the mass of KOH. Yes, what's the molar mass? Let's start from there. KOH, K is what? 39, O is what? 16, H is what? 1. 39 plus 16 plus 1, that's what? 56 gram per mole. Then you have present in 500 cm cube of 2 mole per dm cube solution. So you know that 500 cm cube is what? Your volume. Then concentration is what? 2 mole per dm cube. Yes, so it's just simple. You all know that your mole is what? Mass over molar mass. And you also know that your mole is what? Concentration times volume. Only that your volume must be in what? In dm cube. So to take this one to dm cube, you have 500 over 1000. That's 0.5. So yes, you can just equate these two since they are both equals to what? To mole. What's your mass now? Your mass we are looking for it, over what's the molar mass? 56 is equals to what's the concentration? 2 times what's the volume? 0.5. Mass is equals to 56 times 2 times 0.5. So we have 2 times 0.5, that's 1. 1 times 56, that's 56 gram. That's 56 gram. Yes, let me give you a question like this. Let me give you a question like this. Yes, what's the mass of NaOH present in 25 centimeter cube of 1.2 mole per dm cube solution of the compound? Yeah, so we are looking for mass. Let's get the molar mass. Molar mass is what? NaOH 23 plus 16 plus 1. That's what? 40 gram per mole. Concentration is 25 centimeter cube, that's 25 over 1000. Then you have volume, this is your volume, sorry for that. Then this is your concentration. Volume is always in centimeter cube or dm cube, so this is 0.025. Then your concentration is what? 1.2 mole per dm cube. So let's go now. You know that your mole is the same thing as mass over molar mass, and your mole is also the same thing as what? Concentration times volume. They can give you some other two formulas to relate together. These are the two formulas we are relating in this case, this and this. They can give you this and this. They can give you this and this. Anyone. So you just relate it is equals to each other. So what's your mass? That's what you are looking for. What's your molar mass? 40. What's concentration? 1.2 times volume 0.025. So mass is equals to 1.2, or let me write this first, 40 times 1.2 times 0.025. So yes, let's press it. We have 40 times 1.2 times 0.025. So that's what I got my answer to be 1.2 gram. Yes, so that's just about that. Can play it back and try to watch it again. We are still having problems getting this. Yes, the last question under this case. Last question under this case, we have what mass of SO2 contain the same number of molecules as what? As 0.8 gram of CH4. Molar mass of S32. So this is the question. So let's continue with this question now. What mass of SO2 will contain the same number of molecules as 0.8 gram of CH4? Now, to this question, you actually don't need to stress yourself. The same number of molecules. Mole is equals to number of particles, which can be number of molecules over what? 6.02 times 10 is to the power 23. So these are the only two that is this one is constant, this is a constant. So for two compounds SO2 and CH4 to have the same number of molecules, that means they must have the same number of moles. You get it? For them to have the same number of molecules, they must have the same number of moles. So they are asking you that when will the mole of SO2 be equals to that of what? CH4. So just equate it. Mole is equals to mass over molar mass. This is for SO2. And the mole of this one is also mass over molar mass. This for CH4. What's the mass of SO2? That's what you're looking for. What's the molar mass of SO2? S is 32. Oxygen is what? 16 times 32. That's 32 over 64 is equals to. What's the mass of CH4? This is 0.8 over. What's the molar mass of CH4? 12 plus 4, 16. Mass is equals to 64 times 0.8 over 16. 16 is 64, that's 4. 4 times 0.8, that's 3.2 gram. So that's just that about that. Let's try to take one more question like this so that we can move on to the next questions that we have. So okay, I believe you understand this. You can just try to go through it again. Okay, let's go to the next subtopic now. To the next subtopic. So I've treated the mole concept, how to calculate moles. Yes. So let me just talk on this number of particles. I told you already that number of particles can be what? Atoms, can be molecules, and can be what? Can be ions. Yes, and what's the formula that relates them? Mole is equals to number of particles over 6.02 times 10 raised to the power 23. So what are you going to do? How do we get the number of particles? Yes, this number of let me keep atoms molecule here. Yes, what this thing we call it the what? The Avogadro's constant. So what this man meant was that whenever you have one mole, inside one mole there are what? 6.02 times 10 raised to the power 23 particles. So it's just like you say inside one dozen there are 12 eggs. Or like you say inside one gross or things like that. Okay, yes, let me just play with this. Inside one dozen there are how many eggs? 12 eggs. So inside every one mole there are what? 6.02 times 10 raised to the power 23 particles. Inside two moles there will be what? 2 times 6.02 times 10 raised to the power 23 particles. Just like inside 2 dozen there will be what? 2 times 12 eggs. So inside 3 moles there will be 3 times 6.02 times. Are you getting it now? What of inside 4 moles? 4 times. So I can say something like this. Yes, let's read them one after the other. Atoms. Yes. How many atoms of oxygen are here? 2. O plus O. So this is one atom, this is another atom. That's what gives us oxygen. So here we have 2 moles of oxygen atoms or 2 oxygen atoms. 2 oxygen atoms. So we already know that one oxygen atom, inside one oxygen atom, we have 6 points. Oh, inside we have 6.02 times 10 raised to the power 23 atoms inside one oxygen. Yes. So inside 2 oxygen we have what? 2 times 6.02 times 10 raised to the power 23. The same thing for ions. If you have hydrogen ion, just one, it will be what? 6.02 times 10 raised to the power 23. But if you have 2 moles of hydrogen ions, that will be what? 2 times 6.02 times 10 raised to the power 23. The same thing for molecules. So you just relate it to each other. Let's take a question now. So we just take some questions and we treat all past questions related to it. And that will be all for this case. So let's go now. What's the number of hydrogen ions present in a solution containing 4.9 gram of H2SO4? What's the first thing I told you? I told you that we'll get the what? The mole. So if you get 1 mole, it will be what? 1 times 6.02 times 10 raised to the power 23. If you get 2 moles, it will be 2 times. If you get 0.2 mole, it will be 0.2 times 6.02. So let's get the mole first. So H2SO4, you already know that. How many hydrogen ions are there? 2. This is 2 hydrogen ions. So this is 2 hydrogen ions. So let's get the mole. They said 4.9 gram. So that's what? 4.9 over, we are trying to get the mole mass over molar mass. So this is what? 4.9 over 98. So that's what? What's 4.9 over 98? That's 0 point, then that will be what? 0.5. So you have 0.05 mole here. So if this is 0.05, this is 1:2. So your answer will be what? You can just, this will be what? 2 times 0.05 mole. Do you get it now? So 2 times 0.05 mole. How do I multiply it by 2? It is normally what? What's the number of mole here? 1. What's the number of mole here? 2. So it's 1:2. So that means if this one is 1, this one will be 2. If this one is 2, this one will be 4. It's just 1:2. So if this one is 0.05, this one will be 2 times 0.05. What's our mole now? 2 times 0.05 is what? 0.1 mole. So this is the mole of the what? Of the hydrogen ion. So let's go. If so, we'll just, it will be what? 0.1 times 6.02 times 10 raised to the power 23. Like I explained, that's 6.02 times 10 raised to the power 22 ions, hydrogen ions. Yes. Or if you don't want to take, you can just use the formula. Mole is equals to number of particles, which is number of ions, over what? 6.02 times 10 raised to the power 23. What's the mole? 0.1 is equals to number of ions over 6.02 times 10 raised to the power 23. So here you cross multiply 0.1 times 6.02 times 10 raised to the power 23. That's what? The same thing, 6.02 times 10 raised to the power 22 ions. So please take note of that. The first thing is that you get the moles. After you've gotten the moles, you then get what? You try out, you put it into your formula to get the number of hydrogen ions. The number of hydrogen ions. Yes, let's take this next one together. Once I write the question, you can practice it first before you watch it, before you try it. Okay, yes, let me write it down. So you can first try it. You can first, yes, it's something related to this. What's the number of hydrogen ions present in a solution containing 9.8 gram of H2SO4? This is also a jam question. So let's go the normal way. Just write how many hydrogen ions are here? It's just what? 2. 2 hydrogen ions plus SO4 2 minus. Is that clear? So you have 2 hydrogen ions. Get your mole. Mole is equals to mass over what? Molar mass. What's mass? 9.8. What's our molar mass? 2 plus 32 plus 16 34 64. That's what? 98. That's what? 0.1 mole. So it is 1:2. If this one is 1, this one is 2. So if this one is 0.1, this one is 0.2 mole. Yeah. So if it's 0.2 mole, so you just bring it. 0.2 mole will be what? 0.2 times 6.02 times 10 to the power 23, which is 1.204 times 10 raised to power 23. Yes, you can use the formula method. Mole is equals to number of ions over 6.02 times 10 raised to power 23. This is how we arrive here. So mole is what? 0.2 times 6.02 times 10 raised to power 23 will give you what? Your number of ions. It's also equals to 1.204 times 10 raised to power 23 ions, hydrogen ions. So that's our answer. Any approach you want will still give you the same answer. So just make sure you master the procedure well. You get your mole, then you slot it in into your formula. That will give you your answer. Let's take another question now. I've done ions. Let me treat questions of molecules. Yes, molecules now. Molecules. Yes. How many molecules of oxygen? This is a question. Are there in 8 grams of oxygen gas? So this is very simple. You've been given your mass, so you just get your mole. This oxygen gas, you are finding the number of molecules. So 8 gram mole is equals to mass over molar mass. What's your mass? 8. What's your molar mass? Oxygen gas is what? 16 times 2, that's what? 32. So you have 8 over 32, that's what? 0.25 mole. Are you following? So what should that be? 0.25 mole times 6.02 times 10 raised to the power 23. So if you multiply it very well, you get what? 1.5 times 10 raised to the power 23 molecules. So it's as simple as that. Let's take a question, just one more question on molecules, just to consolidate your knowledge on this. Also a jam pass question. We have how many molecules of phosphorus P4 are present in 496 grams of the substance? We have your P to be what? 31. Yes, let's go now. What's the first thing? You get your what? Your mole. Mole is what? Mass over molar mass. What is this? 496 over, what's the molar mass? P4. P is what? 31. 31 times 4. That's what? 124. Yes. That's 124. So 496 over 124. That will give you what? That will give you 4 mole. So you put it into your formula. Mole is equals to number of molecules over what? 6.02 times 10 raised to the power 23. Or you can as well take it straight 4 times. It will give you the same thing. So your mole is 4. Number of molecules over 6.02 times 10 raised to the power 23. So that's what? 4 times 6.02 times 10 raised to the power 23. That's 2.4 times 10 raised to the power 24. Yeah. Please take note of that. 2.4 times 10 raised to the power 24 molecules. Molecules. Yes. Please take care of that. Take care of that. Let's move on now. Let me go to the last one, atoms. Yes, atom. Yes, let me write the question. How many atoms of oxygen are present in 8 grams of oxygen gas? Yes, what's 8 grams of oxygen gas? This is oxygen gas. Now you need to recognize atoms. What's the meaning of atoms? 1 mole of oxygen gas contains how many oxygen atoms? 2 oxygen atoms. 2 oxygen atoms. Do you understand? So you have, it's actually what? 2 oxygen atoms. So get your mole. Mole is equals to what? Mass over molar mass. This is your mass, 8 over, what's the molar mass? 16 times 2, that's what? 32. 8 over 32 is what? 0.25 mole. But how many oxygen atoms do you have? It is 2. This is just 1 here. So you have, this is it. The mole of this one is 0.25 mole. This is what you just got in. Mass 8 over molar mass 32. That's 0.25 mole. So yes, this one is, they are all in what? 1:1:1. Their mole. What is in that front? 1:1:1. So this is also what? 0.25, 0.25. So you have 2 oxygen atoms, add their moles together, that's what? 0.5. You will not now go all this stress, just multiply it by 2 because you have 2 oxygen atoms. So that's a 0.5 mole. So this is what you use in your formula. 0.5 is equals to number of atoms over 6.02 times 10 raised to the power 23. So you multiply 0.5, I cross multiply, times 6.02 times 10 raised to the power 23 will give you the number of atoms. So if you multiply this one well, your number of atoms will be what? will be 3.01 times 10 to the power 23 atoms. Yes, please take care of that. 3.01 times 10 raised to the power 23 atoms of oxygen. Let's try another one out. Please, if you've not gotten it, you can just play back and try to watch it over again. So let me take another one now. Are present in, let's say, 2.4 gram of ozone. What's ozone? Ozone is O3. How many oxygen atom? O plus O plus O. So the first thing is that to get your mole. Mole is equals to mass over molar mass. What's mass? 2.4. What's the molar mass of this? Oxygen is 16, right? 16 times 3 is what? 48. So that would be 0.05 mole. Now you have three oxygen atom. This is 0.25, this is 0.25, 0.25, 0.25. Add it up, when you multiply this one by 3, you get what? 0.15 mole. So this is what you will use in your formula, which is mole is equals to number of atoms over 6.02 times 10 to the power 23. What's your mole? Mole is what? 0.15 is equals to number of atoms over 6.02 times 10 to the power 23. You cross multiply 0.15 times 6.02 times 10 to the power 23. Yes, if you solve this very well, you get what? This will give you around 0.9. Yeah, 1.9 times 10 to the power 23. That's 9 times 10 to the power 22. Approximately. I did it offhand, so a calculator can give a more accurate answer. So that's just about atoms too. That's just about atoms. Let's just take a jam question on atoms before we move into stoichiometry, the other cases of stoichiometry. Yes. How many atoms of oxygen are present in 8.8 gram of CO2, carbon dioxide? Yes, let's go. How many oxygen are in CO2? How many oxygen atoms? We have what? Two oxygen atoms. Two oxygen atoms. So let's get our what? Our molar mass. This is C plus O plus O. So we have two oxygen atoms. So our mole is equals to what? Mass over molar mass 8.8 over. What's the molar mass for this? Carbon is 12, oxygen is 16 times 2, that's 32. So that's what? 44. 0 point. That's what? 0.2. Do you get it now? 0.2 mole. So if this one is 0.2, then this one will be 0.2, this one will be 0.2. Do you get it now? So we're going to have the two will give us what? That's what? 0.4 mole. So just plot it into your formula. 0.4 is equals to number of atoms over 6.02 times 10 to the power 23. 0.4 times 6.02 times 10 to the power 23. That's what? 2.4 times 10 to the power 23 atoms of oxygen. I hope you get it now. Yeah, that's very good. Let's go into the fourth case now. Yes, yes. Let's move on. So let me rub it off. Then we begin to take practical questions. Yes, more advanced questions now. Yes. So I'm coming. Let me just change the marker. Okay. So we have something like this. We're still on stoichiometry. Yes. Before we move into this next part, there are some things you need to know to be able to solve questions on stoichiometry really well. You must know your what? Your known. When you are given a question, identify your known. Which one is given? Identify your unknown. Which one is not given? Which one is not given? Which one are you to find? Then find the mode of your what? Known and unknown. So with this, how do you get the mode of your known and unknown? You can use any of these formulas. So with this, once these three things are done, you will get your answer straight up. Let's move on now. So let me write the first question now. I'm sorry, I'm trying to draw a better marker. So this is the first question now. How many grams of water would be formed if 0.4 gram of hydrogen reacts with enough quantity of oxygen? So yes, write your equation of reaction. Hydrogen reacting with oxygen to give you what? Water. Then just try to balance it. That will give you what? 2H2, then 2H2. Do you get it now? So yes, they said how many grams of water. I will give you two methods. You can use the mole method and you can use what? The mass to mass method, both to get to your answer. So yes, let's try the mole method now. The mole method now. Yes. So what's the mole method? I said you will find the what? The known. Which one is the known? Okay, how many grams of water? Is that known or unknown? That's what unknown. So you can just say this is the unknown. How many grams of water? Maybe for if 0.4 gram of hydrogen, 0.4 gram, this is your what? The unknown. And what's the value that is known? 0.4 gram. Can you see it now? Yes. So let's try to solve. Mole is equals to mass over molar mass, right? What's our molar mass? Let's get our molar mass. What's the molar mass for hydrogen? Hydrogen, that's what? 2, 1 times 2, that's what? 2 gram. What's the molar mass for this? 1 times 2, 2 plus 16, that's what? 18 gram. That's that of water. That's that of water. Yes, so if you want to use the mole method, so you can just say mole is equals to what's our molar mass? Mass is what? 0.4 over molar mass 2. Mass over molar mass 0.4 over 2, that's what? 0.2 mole. 0.2 mole. So using the mole method, you just check the mole 2:2. So their mole is in what? 2:2. So that means if this one is 2, this one will be 2. If this one is 4, so it's like the same thing. So if this one is 0.2 mole, this one will also be what? 0.2 mole. So this is what you now bring to the formula. Mole is equals to mass over molar mass. So what's your mole? 0.2. What's your mass? 18. Oh, you are looking for the mass, sorry. Then what's your molar mass? 18. So mass is equals is what? 0.2 times 18. That's what? 3.6 gram. So yes, that's the first method, using your mole method. Yes, let me use a shorter method now. Let me give you a shorter method to solving this question. That's using your what? Mass to mass, or maybe mass to volume, as the case may be. Yes, using your molar. Yes, let's go now. Now you want to use this method. This is just what you will do. You get your molar mass. What's the molar mass for this 2? What's the molar mass for this 18? So you multiply it by the mole, the one in front, after you balance the equation. So this is what? 2 times 2, and this is what? 2 times 18. So you already know that 2 times 2 is what? 4 gram of hydrogen will give you what? 36 gram of what? Of water. So they now said what's 0.4 gram? What will 0.4 gram give you? Call it X. In fact, I will advise you go by this method because it's very preferable. You are solving jam. You shouldn't be going by that long method. So cross multiply 4 times X, that's 4x. 0.4 times 36. So divide both side by 4. So this is 0.1 times 36. X is equals to what? 3.6 gram. So this is the second method. It will also give you what? The same answer. Let's take another question like this. Another question like this. So yes, maybe we should stick to a method. Let's just stick to that second method. Yes. Or we can be trying both, just considering the time. Yes, another question now. We have They asked us to, okay, let me write, how much of magnesium is required to react with to react completely with 100 centimeter cube of 0.1 mole per dm cube HCl. Yes, so for this, let's just okay, let's go. You have what? Magnesium. Are you following? And you have what? HCl. So yes, let's go for the first method. So this will give you what? NgCl2 plus hydrogen gas. So this is the equation of reaction. Try to balance it. Yes. So it's balanced now. It's balanced now. Okay, let's move on. They said how much of magnesium? Magnesium is not known. This is your unknown. Just know the two methods in case. Then this is your what? This is your known. What's the next thing? Find the mole of your known. Mole is equals to what? You are giving volume and you are giving concentration. Mole is CV. C times V. What's your concentration? 0.1 times. What's your volume? 100. But I said it can be in centimeter cube. You change it to a dm cube. 100 over 1000. So that's what? That's 0.01 mole. Yes. So check it. This one, in your mole ratio, this is 1 to 2. There's an invisible one here. Yes, you just didn't write it. Yes, because you know already now 1x is the same thing as x. So we have the mole ratio is 1 to 2. So if this is 0.01 mole, this one will be what? Divided by 2. This will be 0.005. Are you getting it? So this is 0.005 mole. Yes. So let's move on now. Magnesium is 0.05 mole. So you say mole is equals to mass over molar mass. Yes, just following the principle of the second formula. I said find your known, find your unknown, find the mole of your known, find the mole of your unknown. So mole is equals to, what's our mole? 0.005. Is equals to, what's the mass? That's what we are looking for. What's the molar mass? 24. Mass is equals to 0.005 times 24. So that will give you what? That will give us, let me just press it here, but I think we can solve it without actually using a calculator. But yes, so I have 0.12 gram. So yes, that's just the answer. That's just the answer. Let me make a sketch of the procedure again. You write your formula, your equation of reaction, then you write out your known, write out your unknown, then find the mole of your known. Then use the mole of your known to get what? The mole of your unknown. So this will always give you the answer. So you follow these 5 steps. Yes, let's take another one now. Let's take another one now because of time. So I'm sorry. So yes, the next question now. We have, please, I'm coming. Let me try to get the question from here. Okay, yes. I have a question. How many grams of HCl will be required to react with 5 grams of NaOH? Be required to react with 5 grams of NaOH. Yes. So let's move on now. I'm sorry. So yes, how many grams of HCl? So you have HCl plus what? NaOH. That will give you NaCl plus H2. That's our first thing. Write your equation and balance it. It's balanced already. Yes. Then they said you should find our known. What's our known? 5 grams of NaOH. These are what's known. We've done this. Find your unknown. What's our unknown? How many grams of HCl? These are our unknown. We've done this. What is the mole of our known? So you get the mole of this one. Mole is equals to, what's our mass? Mass over the molar mass. Na is 23 plus oxygen 16 plus 1. Add it up, that's what? 40. Do you understand? So 5 over 40 will give you what? 0.125 mole. So we've gotten our mole of known. So use it to get what? The mole of your unknown. Yes, they are in what? 1:1. So if this one is 0.125, this one will be 0.125. So mole of HCl is what? 0.125 mole. Then what are you asked to find? How many grams of HCl? So mole is equals to mass over molar mass. What's your mole? 0.125 is equals to what that you are looking for the mass, how many grams over molar mass. What's the molar mass of HCl? HCl 31 plus 35.5, that's 36.5. So your mass is what? 0.125 times 36.5. So you have what? 0.125 times 36.5. So that's what? 4.56 gram. So that's 4.56 gram. So this is my final answer. So just follow this procedure, get your equation, find your known, find your unknown, find the mole of your known, find the mole of your unknown. Then from there you will get that will lead you to your answer. Another question, I'm treating questions from LAMLAD actually. So every question related to this case will be treated shortly. Yeah, let's move on now. So we have another question here. We have another question here. In the reaction, permit me, I may not write the question in fact, just CaC2 plus 2H2. This is the question. Calcium, they gave you the equation of reaction already. They now said, what is the mass of solid calcium carbide needed to produce 5.6 dm cube of what? Of ethyne at STP. So yes, let's solve this together now. So we've been given our equation CaC2 plus 2H2O to give us CaOH2 plus C2H2. Yes, and the equation is balanced already. So yes, let's get our known. What's our known? 5.6 dm cube of ethyne. They've given you known is what you've been given. So this is your ethyne, 5.6 dm cube. So this is our known. What's our unknown? What is the mass of solid calcium carbide? What's the mass? So this is our what? Unknown. Yes, so you get the mole of your known. What's the mole? Mole is equals to know which formula to use. What were you given? 5.6 dm cube volume. Which formula of mole relates volume together? Yes, so that's what? Volume over molar volume. So we have 5.6 over what? 22.4. So mole is equals to what? 0.25 mole. Do you get it now? Yes. So you've gotten your mole of the known. So get the mole of your unknown. They are what? 1:1. 1:1. How do I get 1:1? What is in front of them is just 1. Yes. So if this one is 0.25 mole, this one will also be what? 0.25 mole. So using the formula, mole is equals to mass over what? Molar mass, because you have asked to find the mass. So you've got your mole 0.25 is equals to what? Mass over molar mass. Get the molar mass of CaC2. Ca is 40, carbon is 12. 12 times 2 is what? 24. So this is 64. Then you have mass, which is 0.25 is 64. That is what? That is 16 gram. 16 gram. Yes, let's take another question like this now. If you don't get it, just go over it again. You can just play back and watch it again. Yes, another question. I want us to treat a lot of questions so that you can have a solid knowledge of the topic well. Okay, yes, let's take another question now. So we have another question here. Consider the equation Fe plus 2HCl to give you FeCl2 plus hydrogen. What is the mass of iron that would be required to react with 250 centimeter cube of 0.1 mole per dm cube HCl. F is 56. So yes, let's take the question together now. What's the first thing to do? You write your what? Your equation. You've been given your equation plus 2HCl to give you FeCl2 plus hydrogen gas. So we've done that. Yes, identify your known. Identify your known. You were given 250 centimeter cube of 0.1 mole per dm cube HCl. So this is your what? Your known. Then they said what's the mass of iron? This is your what? Unknown. Do you get it now? Next thing, find the mole of your known. We've got our known, we've got our known. Find the mole of your known. Mole is equals to what will determine the formula to use. Yes, you are giving volume, you are giving concentration. What's the formula of mole you use? Concentration times volume. So what's concentration? 0.1 mole per dm cube. What's volume? 250. But it won't be 250, it will be what? 250 over 1000. That's what. So just got right. So that's 0.25. 0.1 times 0.25. That's what? 2.5 times 10 raised to power minus 2 mole. Do you get it now? 2.5 times 10 raised to power minus 2 mole. Minus 2 mole. So yes, just use that to get your what? Unknown. Use that to get your unknown. So yes, this is what, from the equation of reaction, this is 1:2. 1:2. If this one is 2.5 times 10 raised to power minus 2, what will this one be? It should be what? Divided by 2. Because if this one is 4, this one will be 2, right? If this one is 6, this one will be 3. 2:1, 2:1, 8, 4, 12, 6. Do you understand? So if this one is 2.5 times 10 raised to power minus 2, this one will be this one divided by 2. So this is 2.5 times 10 raised to power minus 2 mole. This for iron, this for HCl. Yes, so divided by 2, that will give you what? 1.25 times 10 raised to power minus 2 mole. So you've got your mole for iron. So mole is equals to mass over molar mass, because you are asked to find the mass. So yes, what's your mole? 1.25 times 10 raised to power minus 2 is equals to, what's your mass? That's what you are looking for. Over what's the molar mass of iron? 56. So just cross multiply. Mass is equals to 1.25 times 10 raised to power minus 2 times 56. That's what. So you press 1.25. I'm trying to press it here. So yes, I have 0.7 gram when I press it in my calculator. You can also press it there. So yes, that's how I got my answer to be what? 0.7 gram. 0.7 gram. I believe you understand. So just follow this principle. You will be getting the questions. Yes. And once you are done with this video, just go to search for the next video after this, advanced stoichiometry. It's also made by Celebrated Achievers Mentorship Program. So you just watch it to solidify your the understanding of this topic. Yes, let's take another question now. Yes, another question on this. We have an equation. Okay, sorry, C4H10 plus so they said what volume of oxygen is required to burn 100 centimeter cube of butane. So yes, follow the normal procedure. You've gotten your equation already. C4H10 plus 13O2 to give you 8CO2 plus 10H2. This is your equation of reaction. Then what's your known? This is 100 centimeter cube of butane. So this is butane. This is your known. What's your unknown? What volume of oxygen? This is your unknown. So they said you should find the mole of your known. What's the mole? This is what mole is equals to. How do you know the formula to use? Check 100 centimeter cube. That's what volume. So you use volume over molar volume. But know that this one is in centimeter cube. So your molar volume will be what? 22,400. I told you that earlier. So this will be, you have 1 over 224. So that will get you your mole. Let me press it here. 1 over 224. So this is what? 4.46 times 10 raised to power minus 3 mole. Do you get it now? Yes. So that's your mole. Yes, just check it out. We want to, yes, they said you should get the mole of your unknown. You've gotten the mole of our unknown. Then you want to get the mole of your unknown. Yes, let me just write it. C4H10. Then you're also dealing with 13O2. If this one is, what's the mole ratio? 2:13. If this one is 4.46 times 10 raised to power minus 3, what will this one be? So you can call it x actually to get your mole. So that will be 2x is equals to 4.46 times 10 raised to power minus 3 times what? Times 13. So you just divide by 2. And this will give you your answer. So that's what? 0.029. 0.029. So yes, this is the mole for your oxygen. So it's this one that you use to get your answer. Yes, what volume of oxygen? Mole is equals to, you've gotten your mole, right? 0.029 mole. So they say what volume of oxygen? What's the formula you use? Volume over molar volume. Your mole is 0.029. What's your volume? That's what you're looking for. What's your molar volume? Yes, 22,400. So just cross multiply. I intentionally stick with this method so that if you are new to this topic, you will understand it really well. Yes, volume is equals to, when you multiply 0.029 times 22,400, you have what? 650 centimeter cube. Yes, yes. So once you just follow this method, you can always get your answer. Let's try another one together. Another question now. Yes, the next question here is 2Al plus 6HCl to give you 2AlCl3 plus 3H2. So they said the number of molecules of hydrogen gas produced when 0.5 mole of aluminium reacts completely with excess HCl is. So this is the question. Yes, write your equation of reaction you've been given. Right? So what's your known? Your known is what? They said 0.5 mole of aluminium. So this is your known. What's your unknown? The number of molecules of hydrogen gas. This is your unknown. So you are dealing with just these two. Yes, what's the mole of your known? What's the mole of this node? They've given you already, so you don't need to stress yourself. So this is 0.5 mole. So just get the mole of your unknown. This 2Al, this 3H2. If this one is 0.5, call this one x. 2 times x, that's 2x. 0.5 times 3. So divide both sides by 2. So that's what? 1.5 over 2. That's 0.75 mole. Do you get it now? So you've gotten the mole of your known too. So yes, From the question, they said what's the number of molecules? Which formula relates number of molecules to mole? That's what mole is equals to number of molecules over Avogadro's constant. So what's your mole? 0.75 is equals to number of molecules over 6.02 times 10 to the power 23. Cross multiply 0.75 times 6.02 times 10 to the power 23 equals to the number of molecules. Number of molecules is what? So yes, press this. What are you going to get? I guess 4.5. Yes, let me press to confirm. Yes, so that's what 4.5 times 10 to the power 23 molecules. Yes. So that's just that about yes. So you get your equation, get your known or your unknown, use it to get the mole of your known, then use it to get the mole of your unknown. Then from there you will get yes. Let's try another one together now. I believe you must have been you are getting it already. Yes. And once you are done watching this video and the second video, make sure you watch the second video too, which is on advanced stoichiometry. Yes, just go ahead, just go to your past questions. Once you are done with the two videos, work and solve every form of questions you can likely encounter under this topic. Yes, next question now. What volume of oxygen at STP would react with carbon to form 13.2 grams of CO2 in the reaction represented below? Yes, so this is it. What volume of oxygen? That's your what? Unknown. We've written our equation. Yes, let's get our known. 13.2 grams of CO2. So this is our known. What's your unknown? What volume of oxygen? This is your unknown. Then find the mole of your known. Mole is equals to yes 13.2 over what? So this is 13.2 mass over molar mass, right? What's the molar mass? Carbon is 12, oxygen is 16 times 2, that's 32 over 44. So your mole is what? 13.2 over 44. That's 0.3 mole. 0.3 mole. Yes. So if CO2 is 0.3 mole, then just get the mole of your unknown. They are 1:1. 1:1. Yes. 0.3 mole. And this one will be what? 0.3 mole. So mole is equals to yes 0.3 mole. What are you have to find? What volume of oxygen? What formula relates volume with mole? Mole is equals to volume over molar volume. That's what volume over molar volume. What's your mole? 0.3. What's your volume? That's what you're looking for. Molar volume is what? 22.4. So cross multiply volume is equals to 0.3 times 22.4. That's what 6.72 dmq. Yes, you can pause this video or play it back and try to solve it on your own in a sheet of paper and see how well you are getting the concept. So yes, this has taken us to the end of basic stoichiometry. Oh yes, let me give one more question as a bonus, but you be the one to try it. You will be the one to do what to try it, and I will make it somehow tough. Yes, on basic stoichiometry. So after this video, go and watch advanced stoichiometry, then solve the questions, every form of questions on stoichiometry, and then you're a champion in stoichiometry. Yes, so I want to give you a very simple question for you to try. The burning of phosphorus . in excess oxygen is represented by the equation P4 plus 5O2 to give you P4O10. They said the volume of oxygen at STP required for the complete oxidation of 18.6 gram of phosphorus is. Okay, will you try it out now? This is your known, 18.6 gram of phosphorus. Then the volume of oxygen, that's your unknown. Okay, yes, try it out. Just pause it and try it out. Now I believe you've gotten it. Yes, let's try it together. P4 plus 5O2 to give you what? P4O10, right? Then just cross multiply. You have oh, I said cross. You've written your equation. So get your known. Your known is what? 18.6 gram of sulfur. So this phosphorus. So this is your known. What's your unknown? This is your unknown. What's the volume of oxygen? This is your unknown. Yes. So get the mole of your known. Get the mole of your known. Mole is equals to what? Mass over molar mass. What's mass? 18.6 over what's the molar mass of phosphorus? Phosphorus here is what? P4. Phosphorus is 31. They are giving you that. 31 times 4 is what? 124. So yes, let's press that. 18.6 divided by 124. That's what? 0.15 mole. Yeah. So if this one, so get the mole of your unknown. You have P4, you have 5O2. If this one is 0.15, and you know they are in what? 1:5. If this one is 0.15, this one is what? 0.15 times 5, or you can call it x. 1 times x, that's x. 0.15 times 5. So that's what? 0.75 mole. So your oxygen is 0.75 mole. So mole is equals to mass over molar mass, right? So mole is equals to, what's your mass? Our mass is what? 18.6 gram over, what's our molar mass? What's the molar mass for phosphorus? That's what? No, I'm sorry. Let's check the question. We've gotten the mole of our oxygen to be what? 0.75 mole, right? So what are you asked to find? The volume. The volume. So which formula relates volume to mole? Mole is equals to volume over molar volume. Yes. So our mole is what? 0.75. We are looking for volume. What's our molar volume? 22.4. Volume is equals to 0.75 times 22.4. So yes, press that. I'm coming. Let me press it from here too. So you have 16.8 dm3. So that's your answer to that. Yes, I feel like giving you one more question again, just to be sure you gotten it. Yes, so try this one on your own. You are trying this one on your own. Yes, so this is the question. How many grams of HCl will be required to react with 5.6 gram of KOH? So K is 39, O is 16, H is 1, Cl is 35.5. Yes, I give you 1 minute. Just pause the video, try it on your own, then resume the video again. I believe you've solved it now. So the first thing is your equation of reaction. What's your equation? HCl plus what? Plus KOH. That will give you KCl plus H2O. Yes, what's your known? 5.6 gram of KOH. This is your known. What's your unknown? How many grams of HCl? HCl. This is your unknown. Yes, so get the mole of your known. Mole is equals to mass over molar mass. Yes, 5.6 over. What's the molar mass of KOH? 39 plus 16 plus 1. That's what? 56. I'm sure you got that. 0.1 mole. I trust that to get it up to this level. Yes. So get the mole of your unknown, your HCl and your KOH. They're all in 1 ratio 1. So if this one is 0.1 mole, this one will also be what? 0.1 mole. So mole is equals to, yes, HCl. How many grams of HCl? What's that? Mass. Mole is equals to mass over what? Molar mass. Mole is what? 0.1. What's your mass? That's what you're looking for. Over what's your molar mass? That's your what? 0. Molar mass of HCl. 1 plus 35.5. That's 36.5. So your mass will be what? 0.1 times 36.5. That will be what? 3.65 gram. So that's the answer to that. I'm sure you got it. Yes. So after this video, just go ahead and search for the video on advanced stoichiometry. Then watch it out. Yes, and try every form of questions on stoichiometry. They will bow. Let's move on now. Yes. Thanks so much for staying through to the end of the video. This is the end of the video on basic stoichiometry. Join us in advanced stoichiometry for a more uh, detailed explanation on advanced questions of stoichiometry. See you then.